Here we will solve some more problems on integration, and we will see how to simplify and solve the question. Okay, so here in the first question you can see it's the integration of the ratio, but we don't have any formula for the ratio, right? We had seen for the differentiation part, if you remember, we had something like integration of du upon dx, differentiation of u upon v, right? And the formula was integration of v with respect to x minus integration of u, differentiation of v with respect to x minus differentiation of u with respect to x divided by v square, right? But we don't have any such formula for integration. So for that, what we need to do, we need to simplify the equation, right? It's not difficult, we'll see. Okay, so here in the first question you can see I can simply add plus 2 and subtract 2, right? So if I add and subtract, I will remain with the same equation, right? So for that I have done adding and subtracting. Now I can separate the denominator. So what I'll get, x plus 2 divided by x plus 2 minus 2 times divided by x plus 2, right? So first term will get cut and we will remain with 1 dx minus 2 1 upon x plus 2 times of dx, right? We know the integration, it's simple. So integration of dx is x minus 2 times integration of 1 upon f of x is 2 times log of f of x plus c. Okay, so simple, right? We need to solve this kind of questions. So next question, again you can see we have the ratio of two algebraic functions, right? But there is a generalized way which you can solve for every question. So I'll show you how to do it. So what we need to do, we need to use the formula dividend equal to divisor into quotient plus remainder. This you have studied in your 4th standard, right? So we need to just divide, right? So we have division of 4x plus 3 with 2x plus 1. So for getting 4x we can multiply 2. So 2 times of 2x is 4x plus 1 times of 2 is 2, right? And we need to change the sign. So we will have 4x minus 4x, 3 minus 2. So we will remain with 1. Now we need to write the equation of 4x plus 3 in terms of the above formula. So we have 2x plus 1 multiplied with 2, that is quotient, plus remainder is 1. Now I can replace this equation in the question. I am separating the denominator as well. So I will remain with this kind of equation. And now it becomes simple to solve this, right? We can cut 2x plus 1. We will remain with integration of 2 dx plus integration of 1 upon 2x plus 1 dx, right? So we know integration of 2 is 2x plus integration of 1 upon f of x is log of f of x plus c, and here we have the coefficient of x, so I need to divide it with the coefficient. So it would be 1 upon 2 log of 2x plus 1 plus c. That's simple. Let's move to the next question. So here to the next question we have integration of 5x plus 2 divided by 3x minus 4. Now again we can use the generalized term, but I'm solving this question because here we don't have the coefficient of the dividend as a multiple of coefficient of divisor, right? 5 is not a multiple of 3. So what we can do, we can make it as 5x, how? By multiplying it with 5 and dividing it with 3. So if I multiply 3x with 5 upon 3, I will get 5x. And if multiply with 4, we will get minus 20 by 3. Now again we need to change the signs, and 5x minus 5x will get 0. 2 minus 20 upon 3. So I'm solving it. So for making the denominator same, I multiplied with 3, divided with 3 and solved. I get 26 upon 3. Again we need to replace the equation in the numerator by using the same formula, dividend equal to divisor into quotient plus remainder. So 3x minus 4 multiplied with 5 by 3 plus 26 by 3 divided by 3x minus 4. We will put the same stuff and we will get the same value. So it's the constant term that we remain with after dividing 3x minus 4 by 3x minus 4. And for the second term, we remain with 26 by 3 integration of 1 upon 3x minus 4. We all know the integration, right? Here we need to keep in mind, we should not forget to divide the term after integration with the coefficient of x. So it will become 26 by 9. Let's move to the next question. Again, it's not that difficult. We can solve it with the division formula, but we can also simplify this, right? You can see if I add 5 and subtract 5, I will not change the equation, but I can simplify it, right? So I did the thing. Yeah, so what we can see, we will remain with x plus 5 divided by root of x plus 5 and minus 7 divided by root of x plus 5. Now again we can easily solve it, right? So we will remain with root of x plus 5 because in the numerator we have x plus 5 divided by we have root of x plus 5. Now I'll just make you find this formula, that is 1 upon root of function. So I'll solve with 1 upon root of x. 1 upon root of x can be written as x raised to minus 1 by 2. Now I need to integrate this. So we need to use the same formula, x raised to n plus 1 divided by n plus 1. So x raised to minus half plus 1 divided by minus half plus 1. We will remain with x raised to plus half divided by plus half. That's simple, right? Now we will use this formula whenever we required, which is 2 times of root x. So you can directly remember this as well. So what we will get here, so here we will get x plus 5 raised to 1 by 2 plus 1 divided by 1 by 2 plus 1 minus 7 times x raised to x plus 5 raised to minus half plus 1 divided by minus half plus 1. Okay, I could use the same formula, but I'll write all the steps so that would be easy to understand. So we can just add 1 by 2 plus 1, we'll get 3 by 2 divided by 3 by 2. We'll make 2 to the numerator minus, here I will get x plus 5 raised to half divided by half, right? So I will just multiply with 2. So you can see it's not difficult. Integration is not difficult. Rather, we just need to simplify and use the knowledge we have earned in the previous years. That's it. It's not difficult. Okay. Now again, we have similar kind of ratio of two algebraic functions. We can use the division method, or we can just smartly play with the numbers So what I can do, I can multiply and divide it with 2. I'll not change anything, right? So if I multiply with 2 to the numerator, it will get multiplied, and in the denominator also I need to multiply, right, to keep the equation same. So 2 times of root of 4x minus 1 times dx. Now we can solve it easily, right? So 2 times of 2x, it's 4x, minus 2 times of 7 is minus 14, divided by root of 4x minus 1, and the term 2 in the denominator, I'll make it out because it's a constant term. So we can keep it out of the integration, right? So we can solve it easily. 4x minus 14 can be written as 4x minus 1 minus 13 divided by root of 4x minus 1. Now we can separate the denominator for different terms. So I will have 4x minus 1 divided by root of 4x minus 1 times dx minus 30 is the constant term, so I'll take it out of the integration. I can take it out of the integration, I'll not take it here. You can keep it inside as well. And the brackets are very important here because half is multiplied with both the terms, right? So I need to use the brackets. Now you can further solve it similarly, right? It's simple, like the previous question. So for the next question, you can see it's sine 4x, and we don't have any standard formula to solve sine upon cos directly. Just having different angles. So what I can do, I can use the simplification equation. So we can use double angle formula. If you remember, sine 4x can be written as 2 sine 2x cos 2x. In the denominator again we have cos 2x, right? So the term get cancelled. We will remain with 2 times of integration of sine 2x. We know the integration of sine x, it's minus cos x, so it will be minus cos 2x plus c, and we need to divide the term with coefficient of x, that is 2, right? So we will remain with minus cos 2x plus c. So let's move to the next question. It's root of 1 plus sine 5x. We have already solved a similar question, the previous part, that was like this only, right? So we can simplify. Whenever you see this kind of question, you can simplify it, right? I'll again use the double angle formula. You need to remember this thing. Whenever you see a question like this, 1 plus sine term, you need to use double angle formula and follow the same procedure for that question. Okay, so sine 5x, I can write it as 2 times of sine 5x by 2 multiply by cos 5x by 2, right? Now what further I can do, we know cos square theta plus sine square theta is always going to be 1, right, for any theta. So for any angle we can write it as 1. So here I can replace 1 with sine square 5x by 2 plus cos square 5x by 2 plus 2 times of sine 5x by 2 cos 5x by 2. So now it looks like a plus b the whole square, right? The expansion of a plus b the whole square. A square plus b square plus 2ab. So I can simply replace it with square root of sine 5x by 2 plus cos 5x by 2 the whole square, right? So square and square root will go, and we will remain with the integration of sine 5x by 2 plus integration of cos 5x by 2. Now this is simple integration. You can solve it by your own So don't need to worry, right? So these are some easy questions that you can solve. You can expect in the exam as well. Okay. Now again, here is another trigonometric question. Here also we don't have any formula for cos square x, right? So again we need to simplify. We need to use some formulas that we know, right? So we know cos 2 theta, we can write it as 2 times of cos square theta minus 1. Now we need cos square x, so we need cos square theta. So I can rearrange the equation. What I'll do, I'll make minus 1 to other side, so it will be 1 plus cos 2 theta. On the right side we have 2 cos square theta. So I can write cos square theta as 1 plus cos 2 theta, 1 plus cos 2 theta divided by 2. Similar type of question we can solve for, like if they have asked for sine square x, we can do the similar thing, because we know cos 2 theta can also be written as 1 minus 2 sine square theta. So again you need to do similar kind of thing to solve the question. Okay, now let's replace the equation of cos square x with 1 plus cos 2 theta, cos 2x divided by 2 dx. Now you can separate the denominator for both and solve the question. Now, this is again another type of question. Whenever you see this kind of question, what you can do, you can easily do rationalization, right? Whenever you see this kind of question, what you need to do is rationalization. We have already done rationalization for trigonometric functions, so it's simply you just need to change the sign in the denominator and multiply numerator and denominator with that term. So here it is root of x plus 3 divided by root of x plus 3. So we are not changing anything in the equation because we are neutralizing it by dividing as well. So let's solve this. So in the numerator we have 2 times of root of x plus root of x plus 3. In the denominator we have a minus b multiplied by a plus b. So you will get a square minus b square, right? So what I'll write, root of x the whole square plus minus root of x plus 3 the whole square. So square and square root will go and we will remain with the simple problem, right? So here 2 times of root x plus root of x plus 3 bracket complete dx divided by root of x square is x minus root of x plus 3 the square is x minus 3 x plus 3, right? Now here the brackets are very important, because if you don't use the bracket you will directly change the value, right? So that you need to remember and be careful with that. Now you need to change the sign. So minus of x and minus plus 3 will give you minus 3. So plus x minus x will go, will remain with minus 2 by 3, right? Integration of root x dx plus root of x plus 3 dx. Now we know the formula, we can use the formula for x raised to n and solve this question. Okay, so I'll leave it on you. It's half plus 1 divided by half plus 1 plus x plus 3 raised to half plus 1 divided by half plus 1, right? So we will get x raised to 3 by 2 divided by 3 by 2. And in the second term as well we have similar thing. So I took the 3 by 2 as common. So in the bracket I will remain with x raised to 3 by 2 plus x plus 3 raised to 3 by 2. You can further simplify the coefficient of the bracket. You get something like minus 4 by 9. You can solve it as well, right? You can keep this much as well. If you keep this much, that is also fine. Last question was similar to this, so we'll move to the further question directly. Okay, so now you need to know this question is really important and you need to understand this very nicely, because for those who are taking JEE and NEET exam, for them this kind of question is really very important and significant, because in mechanics when you solve the questions you will find this kind of questions. So they will give you some kind of equation in terms of time, which is like a double differential equation or something like that, and then you need to solve. And if you remember, when we have solved the integration, when I introduced you, there was some important things that I told you, right? So I'll show you with the example. So here we have the function with respect to time. It's actually the double differentiation. So they will give you this kind of function and they will give you some they will ask you to find some numerical value. Okay, so if it's double differentiation, you need to integrate it twice. So when you first integrate, you'll get df of t divided by dt, and when you integrate it again, you will get f of t. Right, now you need to find f of 2, but there is a twist, right? If you remember, I told you when I started the integration, you will always get something which is plus c, right? That constant term. And for that constant term, you always need some extra information. So in the question, they will always give you some extra information that is called as boundary condition or initial condition. Okay, and this will help you lifetime. So whenever you will solve the question something like this, you need some initial information, right? In the question it is given as f of 1 equal to 11 by 2, right? By using that information you can solve the equation and you will get the value for c as I solved it here. So you always need to remember this kind of thing. Okay, it's really important for engineering students, those who want to take engineering, and for other students as well who are into the chemistry. You have Arrhenius equation, so at that time also in thermodynamics also you will see such kind of equation that you need to solve with integration and find the basic equation. Okay, and you always need to follow the similar kind of procedure. So we will get more insight about it by solving this equation. So let's start. So here in this question you have dash of x, means the first differentiation, which is given as x minus 3 upon x cube, right? So for making it f of x, what we need to do? Simple, I have already told you, right? So if it's differentiation, we need to go back to f of x, then we need to do the integration with respect to x. If it's differentiation with respect to x and you need to go back to the function f of x, you need to do the integration with respect to x. So that's all what what we need to do and then use the remaining information for solving the remaining problem, right? So f of x will be equal to integration of f dash of x dx. Let's substitute the value x minus 3 upon x cube dx. You need to integrate this. It's simple integration. You need to use the formula of x raised to n, right? So it will give you x raised to n plus 1 divided by n plus 1, right? So let's solve. So x will give me x raised to 2 by 2 minus 3, and x raised to 3 in the denominator will give me x raised to minus 3 plus 1 divided by minus 3 plus 1, that is x raised to minus 2 divided by minus 2, and we need to keep the c in the equation, right? So minus minus will get cancelled, remain with plus 3 upon 2x square plus c, right? Now we got the equation f of x, but there is a term c that we need to find out. For that we need to use the condition, that is f of 1 equal to 11 upon 2. So wherever you see x in the equation, you need to substitute it with 1. Right? Now we have f of 1 as 11 upon 2. We can solve the equation 1 upon 2 plus 3 upon 2 into 1 plus c, right? Now 1 upon 2 plus 3 upon 2 can be added and we will get 4 upon 2, right? And we need to take that 4 upon 2 on the other side to find c. So it will be 11 minus 4 upon 2 equal to c, and we will get 7 upon 2. So it's that simple, we can find it easily, right? Now you need to put this c in the equation f of x to get the complete equation of f of x, right? So it will be x square upon 2 plus 3 upon 2x square plus 7 upon 2. So I hope everything is clear for you. It's not difficult, it's really simple. You just need to know the basic mathematics and you need to use your smartness to solve this kind of questions, right? I hope everything is clear and you can solve more problems on this. So that's all. Thank you so much.